Hello everybody, welcome to a YouTube video. Today we're doing solving quadratic equations. This is GCSE level. To solve an equation, we are being asked to find the roots of the graph. And what that really means is, where does it cross the x-axis? So you can see here, this question here, solve x squared plus 14x plus 24 equals 0. I've taken the graph of what this looks like, and we can see that the roots in question is minus 12 and minus 2, these coordinates. That is the roots, that is where the graph crosses the x-axis here. What we'll do is I will solve this now for you, just to show you that these are the roots, okay? So we've got x squared plus 14x plus 24 equals 0. When we are solving, there's two methods. We've got factorising, or we've got using the quadratic formula. Now, all of these questions are through factorising. The way you can sort of tell is if there's a multiple of the second number here, 24, two multiples that add up or subtract to make this second number here. So what I'm going to do now is just write down the factors of 24. So we've got 1 and 24, 2 and 12, 3 and 8, we've got 4 and 6, and we can see here that 2 plus 12 is going to equal our 14 here. So we know that these two here are going to be our factors, okay? So let's factorise this. We've got x in one bracket, x in the other, and this is going to equal 0, okay? So what we can do is we can do plus 12 and then plus 2. That is it factorised, but we're asking to solve it. So we've got x plus 12 equals 0. So that means that x must equal minus 12, because if this is 0, that must be minus 12, because minus 12 plus 12 is going to be 0. And then the same thing here, or x plus 2 equals 0, which means x must also equal minus 2. Now we're given that, it's equal to 0, which is like our y coordinate. So we know that the points where it crosses is at minus 12, 0 there, and minus 2, 0 there. So that would be it solved. This would be your answer. X equals minus 12 or x equals minus 2. Okay? What I'll do is I'll give you a moment just to try these other two questions. You might find it a bit trickier on the third one, just you might not have seen it before, where the quadratic element has a coefficient in front of it. But if not, you can sit and watch me just do these next two questions. I'll just quickly rub this out. So what we've got next is y squared plus 9y plus 2 equals 8y plus 57. So if you haven't seen it so far, what we are required to do for this one is to slightly manipulate the equation, just to get it in that quadratic form of ax squared plus bx plus c equals 0. Okay, so that's our first step. I'm just going to just write this out. Plus 58. So what I'm going to begin with is minusing 8y off this equation from one side to the other. So minus 8y. So we've got y squared, and then 9y minus 8y is just going to leave us with y, plus 2 equals 58. And now if we see these other questions, we've got 0, 0, and to solve it we must have it equaling 0. So what I'm going to do now is just minus 58 off both sides. There we are. Y squared plus y, and then that will be minus 56. So similar to the first question, I'm just going to write down the factors of 56 here. We've got 1 and 56, 2 and 28. It doesn't go to 3, 4, 5. So I think the next one will be not 6, 7 and 8. So what we can see is we're trying to make 1. If you think about it, this is just a 1 in front of the y. So I think what we're going to do is have these as our factors. That's what we're going to use. So 7 and 8. 8 minus 7 is 1. So we're going to write that out. So similar to before, I'm going to start each bracket with y, and then just have it as 0, because that's what it needs to equal. And remember, we've got to make it a minus, so one of them has to be plus, and one of them has to be minus, okay? So what I'm going to do is, let me just think about it. So we need to make positive, so it's going to be minus 7, plus 8. Because if we expand this in our heads, that'll be y squared plus 8y minus 7y, which gets us 1y, and then minus 7 times 8 is 56. So if we just solve this, we've got y minus 7 equals 0, so that means y will equal 7. Or our second solution is y plus 8 equals 0, so y must equal minus 8. There we are. Those are your two answers. There's one there. If it asks you for your coordinates of where the roots or solutions are, it would just be 7, 0, or minus 8, 0. Because remember, we're solving it, so it's 0 here, okay? Right, I'll just rub this out, and then we'll crack on with the third question, which is slightly different. It's got a bit more to it, but not too much. It's the same concept of putting it into the brackets, just with a slightly different method to deal with that coefficient in front of the x squared. Bear with. There we are, that's all gone. Right then, let's write this out. So we've got 6x squared plus x, minus 15 equals 0. So the method to deal with when you've got a coefficient in front is what I call the a times c method. If you think about it like this, plus c equals 0. To get rid, or not get rid, but deal with this a, when it's a number, it's not just x squared, is we multiply these two here. So if we do a times by c, which is 6 times minus 15, that gets us minus 90. Okay, now we're going to find the factors of minus 90. So I'm just going to do the second number as the negative, just for this example, but either number, that could be negative and that could be positive in this scenario. Okay, so we've got 2 and minus 45, 3 and minus 30, we could have 5 and minus 18, or we can have 9 minus 10. So if we look back at what we're really solving here, we're looking for x, just a 1. Remember, this is just a 1 in front of it. If we look at these two numbers here, we know that some manipulations to this will make 1. So minus 9 plus 10, that's going to be 1. Bit of a dodgy one, but that's going to be 1. Okay? So it knows that these are the right numbers or the factors to use. What we can do to this equation, if I just take it down here, is we can rewrite it, because we know that this singular x is the same as, so write it as minus 9x plus 10x. It's the same, which means the same as just x, because that's just simplified, okay? So we can rewrite this in a longer way. 6x squared minus 9x plus 10x minus 15 equals 0. Pop a line down the 2. So we've got two different sides to it. And then what we're going to do is going to factor each side, okay? So what goes into both 6x squared and minus 9x? Well, that's going to be 3x. Both factors are 3 and both have x in them. We'll do a second bracket here. And then we'll pop 2x there, and then a minus 3 there. Now we're going to copy this bracket over onto this side, okay? And then we need to find whatever goes into, what was multiplied here to make these numbers up here. So, or we can do it the inverse way and divide it. So 10x divided by 2x, well, 10 divided by 2x is just going to be 5, and we'll just check that that works here. So 5 times minus 3 is minus 15. So now we've got two brackets. That's one bracket, and then this is the other bracket. These two together. So we've got 2x minus 3 as our first bracket, and 3x plus 5 as our second bracket. Okay. Same as before, we will just set the bracket to 0. So 2x minus 3 equals 0. We'll do 2x equals 3. There we are. So that means just x is 3 over 2. That's a really bad 3. There we are. And then same with this one, 3x plus 5 is 0. There we are, that's better 0. 3x equals minus 5. So then x equals 3. Minus 5 over 3. There we are. I'll just write that a bit neater. Minus 5 over 3. So that one there and that one over here would be your two solutions to this question. Solving that equation, these would be your solutions where it would cross the graph. So what's that, 1.5? So so about there-ish, and then minus 5 over 3, maybe it'd be around there-ish. That would where it would cross the graph. A way you can check this is you can take your values that you've got at the end and just pop them in where you have x. So 6, and then 3 over 2 squared, plus 3 over 2 minus 15 will give you 0. And if it gives you 0, you know that you've got the right answer. Okay? Hopefully you found this helpful. Any questions, pop them in the comments, and I'm more than happy to reply. Thank you.